Hello, ladies and gentlemen. It's Mrs. Notzel. I cannot believe that this is our last week of e-learning and our last week of school for this school year. I know things have been crazy and it's been hard doing all of this e-learning and not being in the classroom. We miss you all so much and we'd much rather be in the classroom. But this week we're going to finish up lesson 29. We were still working on analyzing the data in statistics and probability. So we're going to focus on the mean absolute deviation, or MAD. So we're going back to that same problem that we were working with last week, where we're talking about the Death Valley National Park temperatures. And in order to, what the mean absolute deviation actually is the difference from the data to the mean. So remember, when you find the mean of a set of data, you add all of the numbers up and then you divide by how many numbers you have. So looking at this table, I see that I have 5 numbers across and I have 3 rows. So I know that I have 15 numbers. So I would add up every single one of these numbers. So 99 plus 113 plus 99, and I keep going, adding up each one of these numbers, and then I divide it by 15. And it tells us that you can make a table to find the absolute deviation. So they know that our mean, they already found the mean for us, and our mean is 89 and 3/10 degrees Fahrenheit. So that is our mean. So then when you have 99 degrees, 99 minus 89 and 3/10 gives us a difference of 9 and 7/10. So our absolute deviation is 9 and 7/10. Now, the word absolute is like absolute value. Okay, it's, remember, we put the 2 bars. Sometimes it would look like this. I'll show you. It would look like this, where you'd have the 2 bars and then you would have a number on the inside of those 2 bars. And then if you had like a negative number in those 2 bars and you had the line, it was the absolute value. The absolute value is the distance from that number to 0. So no matter if you have a positive or a negative number, it's just that the distance from that number to 0. Same here with that absolute deviation. Okay. So what I wanted to point out is they went ahead and subtracted everything for you. So 89 and 3/10 minus 88 gives you negative 1 and 3/10, but the absolute deviation is 1 and 3/10. So once you get all of the absolute deviations for all of the temperatures, then you add all of them up and you would get 119 and 3/10, and then you divide that by 15 and you get 7 and 95 hundredths. That is your mean absolute deviation, or your MAD. Okay, so I just wanted to make sure that I was clear and taught you exactly how to solve that. So you can make a table and you find the average again. So you add them all up and you divide it by how many you have. Okay, so let's take a look at number 7. All right, so I already put the text box in there. And let's go over a little bit. What does the MAD mean within this context? So let's see. So the MAD means on average, because we found an average. So on average, the temperatures, I want to make sure I'm spelling everything right. Sorry, guys. Vary. The temperatures vary by 7 and 95 hundredths degrees from the mean of 89 and 3/10 degrees Fahrenheit. Oh, I spelled this wrong the last time too. Okay. So they tell us that the MAD, or the mean absolute deviation, is 7 and 95 hundredths. they told us that the mean was 89 3/10. So what does the MAD mean? It means on average, the temperatures varies by 7 and 9/500 degrees from the mean. Okay? Number 8 says, given this context, does the MAD value indicate a high or low variability? Okay, so I hope you had a little bit of time to at least just think about it and everything like that. So given this context, does the MAD value indicate a high or low variability? So make sure my cursor is there. And I want to say with 15 temperatures, because that's how many temperatures were listed in the chart, with 15 temperatures recorded, on average, no, I meant to say an average deviation of 8, because 7 and 9/500 is pretty close to 8 degrees, from the mean is a high variability. There is a pretty large temperature difference between the low 80s and high 90s. So the mean absolute deviation value indicated a high variability because there was a variability of 8, which is kind of high. All right, so if you replace the outlier 113 degrees Fahrenheit with 100 degrees Fahrenheit, what happens to the MAD? Well, because you're changing one of the values, it's going to change the mean because you're using the numbers to add them together to find the average. So it's going to change the mean. So the MAD deviation, no, I don't need to say deviation. MAD decreases from 7 and 9/500 to 7 and 900 because the sum of the absolute distances from the mean decrease. So all that's saying is that if we were to go up here and instead of having this 113 degrees, we had 100, that's going to be 13 degrees less. So when we add all of these up, we're going to get a lot smaller of a number, not a lot smaller, but we're going to get a smaller number. It's not going to be 7 and 9/500. Okay, so within this context, how are the mean and the MAD different and how are they related? All right. Well, the mean is a measure of the center of all the data values. The MAD is a measure of variability. So basically, the mean is a measure of the center of all the data values. So you're taking all the data values and you're trying to find the mean or the average of that set of data. The MAD is the measure of the variability or the distances of how many degrees it is from the mean. So you have to know the mean in order to be able to find the MAD. So that's how they're different. But they're the same. They are the same because they are both averages. So you add them both up to divide by the total number that you have. Are the mean and MAD typically affected by outliers? And the answer is yes, because you have to use the values to add them up. So the answer would be yes. The mean changes when high or low outliers are removed. And then changing the mean will always or will also change the MAD. Because you base the MAD off of the mean, so it's always going to change it. So I hope that makes sense to you. I know some of these questions are a little bit wordier and a little bit too much sometimes. But you're going to have a question where all you're going to have to do is answer questions about what the MAD is, like what is it, and then how do you find it. So again, to find the MAD, you have a set of data, you have to find the mean of that set of data, and then you have to find the difference of each one of those data points from the mean. Then you put them in a table like this, you add them all up, and then you divide them by how many you have, and that's how you get your MAD. If you have any questions, please reach out to Ms. Walker or myself. We'd be more than happy to help you. We hope you guys have a great day, and we miss you.